Hello, everyone. My name is Sudhakar Mali. Today, I'll be discussing key concepts from a Red Hat blog on designing multi-tenant GPU infrastructure. As AI workloads continue to grow, organizations need ways to efficiently share GPU resources while maintaining strong isolation, security, and predictable performance. This presentation explores how Red Hat approaches this challenge across virtualization and Kubernetes environments. This blog addresses a growing challenge in modern AI infrastructure. GPUs are expensive resources, and organizations want to maximize utilization by sharing them among multiple users and workloads. However, sharing introduces risks such as performance interference, security concerns, and resource contention. The article explains architectural strategies to balance utilization with isolation. As AI workloads move from experimentation into production, enterprises increasingly consolidate GPU resources into shared environments. While this improves utilization and reduces costs, it can also create interference between workloads. Organizations therefore need infrastructure that provides both strong isolation and efficient resource sharing. Red Hat examines how virtualization and Kubernetes technologies can work together to achieve this balance. Effective GPU isolation must be enforced across four independent layers. First is a hardware isolation layer, which determines ownership of physical GPU devices. Second is a fabric isolation layer, which governs communication between GPUs through high-speed interconnects. Third is scheduler isolation, which controls how orchestration platforms allocate GPU resources. Finally, virtualization isolation determines how GPU resources are presented to individual workloads. Together, these layers create a comprehensive framework for multi-tenant GPU environments. This diagram illustrates how isolation is enforced across all four layers simultaneously. Each layer contributes a different protection boundary. Hardware separates physical resources. The fabric controls communication pathways. Virtualization creates tenant-specific environments. And schedulers ensure resources are allocated correctly. The key takeaway is that no single layer is sufficient by itself. True multi-tenant isolation requires all four layers working together. Hardware isolation assigns GPUs directly to specific tenants using mechanisms such as PCI device assignment or IOMMU. This prevents unauthorized access between tenants. Fabric isolation focuses on communication pathways between GPUs. Modern GPU clusters often use high-speed interconnects such as NVLink or NVSwitch. Without proper segmentation, workloads may communicate across boundaries. Fabric isolation ensures that only intended communication occurs. Scheduler isolation is equally important because orchestration platforms make resource allocation decisions. If scheduling policies are not properly configured, workloads may be placed on unintended GPUs or communicate across isolated domains. Best practices include topology-aware scheduling, affinity rules, resource partitioning, and continuous monitoring. These controls help maintain performance while preventing cross-tenant interference. There are several deployment models available. The first is full GPU pass-through, where a physical GPU is dedicated to a single workload. This provides maximum isolation but lower utilization. The second uses hardware partitioning technologies, such as NVIDIA MIG, allowing multiple isolated instances on one GPU. The third approach is time-sliced or shared GPU access, which maximizes utilization but requires stronger software controls. The choice depends on organizational priorities for performance, isolation, and resource efficiency. Operational management remains critical after deployment. Organizations must carefully manage driver updates, firmware consistency, and resource discovery. A change affecting one tenant should not negatively impact others. Strong lifecycle governance and monitoring help maintain stability, prevent configuration drift, and ensure reliable multi-tenant operations over time. Looking ahead, GPU infrastructure will continue evolving as AI adoption grows. Emerging technologies will provide more sophisticated resource management and policy-driven automation. The central message of this blog is that successful multi-tenant GPU environments require isolation at every layer of the stack. By aligning hardware, virtualization, orchestration, and operational processes, organizations can achieve both high utilization and strong security while supporting modern AI workloads. Thank you for your time and attention. As highlighted in the quote, innovation thrives when vision meets execution. Building scalable and secure AI infrastructure requires both a clear architectural vision and disciplined implementation. I'd be happy to answer any questions.